Our next speaker has arrived. Hello, Michael Keller. How are you doing?
Doing good. How are you?
I'm doing well. Thank you for joining us. I guess we're going to get this is the beginning of our API hour. We have a number of talks that are going to talk about different web APIs for PostGIS, and you get to be the first one in.
Awesome.
Yeah. So, how long have you been a PostGIS user?
Ooh, good question. I would say since around 2016.
Okay. And what brought you
So
to PostGIS?
just really was starting to use data. So in college, started to get more and more bigger data sets that weren't working on desktop software. And someone's like, hey, go try this out. And lo and behold, load data into PostGIS and it works much faster than a desktop.
Cool. Awesome. Well, why don't you take over the screen and start
Sure.
whenever you're ready.
Yeah. All right. Hopefully you are able to see.
You can see it all. Looks good.
Perfect. All right. So, hi everyone. My name is Michael Keller, and today I'm going to be presenting on an API that I created called Fast Collections. So, kind of broke this up into three parts here, going first over what is Fast Collections, then giving you guys a little overview of kind of the different endpoints that are available for the API, and then kind of the more fun part is actually going into some demos that I made that actually are using the API so you guys can kind of see not only what it is, but what you can do with it. So quickly kind of going over how it's built. So Fast Collections, it's an API that I wrote using Python that's using the Fast API framework. And in order to kind of get everything wrapped up and connect back to Postgres with PostGIS, we use async PG in order to do data pooling to basically pass those queries back and forth between the API and the database. And then in terms of doing validations for the inputs and outputs for each individual endpoint, we are using Pydantic and GeoJSON Pydantic. And then for the endpoints that do allow you to do filtering, we're using the PyGeoFilter package to help kind of validate what those filters that people are passing in. And then using OGR to OGR specifically for an endpoint where we actually allow people to download the data directly from an API endpoint. So probably a good question. I'm sure you guys have all seen. There's another API that's doing something very similar to what a bunch of other people have already done. And I've listed a couple here. A lot of these have already actually been presented on at PostGIS. So kind of why is this being done again? So kind of for my own, I like to learn and building an API from start to finish and understanding the entire ecosystem allows you to truly understand what you're doing, why you're doing, and also better learn how you can make things more performant. And then what I also found is specifically for some things that I was interested in, none of the current projects had a direct endpoint in terms of some additional functionality that I wanted to enable that could give you further insights into whatever types of geospatial data you have sitting within your database. In terms of OGC compliance, across the board, it follows the core for all three of common features and tiles. And then specifically in terms of features, I do allow the part 3 for filtering, and then part 4 for create, read, update, and delete. And then just going back to tiles, just following the part 1 of core. Didn't follow the part 2 for the multi-projection. Um, just didn't have time to do that. And at least for me specifically, I didn't feel like I had a need for that, so I didn't build that out. So kind of going into the actual endpoints that are available for the fast collections. These are all of the standard OGC API endpoints. Just kind of going through them, we have the collections endpoint, which will simply list out all the geographical data sets that you have within that database. The collection itself to get information about that individual collection, where in this case, how I have it set up, you'll pass in the scheme and the table. And then continuing down, we have things related like the queryables to get all of the different fields and the field types that are available for you to use. And then a multitude of different endpoints for updating, creating, deleting, modifying, or pulling back items in a GeoJSON format. Then we also have the delete item endpoint, and then 3 additional endpoints for specifically dealing with the vector tiles that are generated from the database. And then in terms of some custom endpoints that I added on addition to your standard OGC API endpoints, I did enable a caching mechanism for the vector tiles that right now it just sits in kind of your choice of where you would want that to sit in a folder structure. And I added 2 endpoints to basically one view what the cache size is. So you can basically see one is data being cached and then how much data is being cached. And then also a method where if you're updating a data set in the background through some sort of cron job, or you're just manually going in and updating a new data set, a way for you to force that tile cache to be deleted. So that way the next person to hit that endpoint would be pulling in new tiles and have those tiles going forward be cached. And then a couple of different endpoints related to specifically numerical columns within each of your data sets to do things like perform statistics. So what is the average, sum, max, minimums, pulling distinct values? And then a couple of different endpoints related to helping you either build choropleth maps, build out graphs, and other things within your own custom web applications. And then also an autocomplete service. So if you have any types of forms, so addresses, whatever it may be, and you want to give a autocomplete service to people, there's an endpoint for that. And then also giving people not just the ability to update and delete the data, but also potentially to add or delete columns within their database as well. And then find things like the closest X amount of features, and then the capability to download that data if need be. In terms of integrations, if you do host this, you can directly pull it into QGIS as an OGC API. Similarly with other Esri products, you can do that as well. Or if you are building your own custom applications, you can directly integrate with these API endpoints in order to do what you would like to do with them. So with that, I'm going to go and jump into some demos here of using the FastCollections API. So first one that I have here, it's just using 2 endpoints here. We have the vector tile endpoint, the tiles endpoint here to actually see here are a bunch of counties within the US. And then we're also using the queryables endpoint here to basically get a listing of here are all of the available columns for this individual collection. And then I can dynamically refresh the tiles by passing in different SQL filters. So for example, I can say the state name is equal to Illinois. Go ahead and click filter, and this will go not client side. So like if you pull back all vector tiles, you could obviously do this on the client side with Mapbox expressions or things like that. But this is actually truly going all the way back to the database so that all of the tiles in areas where they're not meeting that condition, it's not pulling back data just to reduce the amount of traffic back and forth between the client and the database. And then you can continue to just do things like, let's say we're interested in looking at population. So what counties have less than 1,000 people within them? I can reapply that filter. It'll recall the vector tile endpoint to quickly pull back. Here are a listing of all the counties that have less than 1,000 people. And you could basically go ahead and do that for any sort of normal SQL conditions. I like, likes, starts with, ends with, is available for consumption. This is using the statistical endpoint here. So right now I don't have any data that's actually being displayed on the map. one of the reasons is I have all of the addresses loaded for the state of Wisconsin, which is 2.7 million points. So trying to pull that in as a raw point data set, obviously it would not load within the browser just due to how much data would be processed. So we can actually use the statistics endpoint versus doing something like hexagon grids or square grids, kind of any choice of aggregation, administrative, to go against the database and get the raw counts of what's happening. And then one of the attributes for each address is the city and zip codes. So I'm just doing a tell me all distinct possible cities. And behind the scenes, if you wanted to, you can actually list out all those 462 cities and how many addresses are tied to each of them. I'm just not showing that here in this specific example. And then I'm also pulling from the county's data set to just do a sum of total households and an average of the household size. So each time I zoom here, this will go ahead and go back to the database and recalculate these numbers here each time I'm zooming. So you can see here, all of these will continue to update based off of when I'm panning on the map so that I can quickly assess, in this case, and in my map extent, how many addresses are there, number of cities, number of zip codes. And eventually, once I do get down to a certain zoom level, I do enable the vector tile endpoint to start rendering all those addresses so that we can actually see them on the map. And once you hover over them, you can also just see what those individual addresses are. So this is just kind of to give an example here of that statistical endpoint and how it could be useful is if you are using extremely large data sets that can't be necessarily rendered on a map that you want to get certain statistical information on, you can use that endpoint. This is jumping over to using that autocomplete endpoint, which was one of the additional endpoints that I added. Same thing, I'm going to use that Wisconsin address data set where I can simply just start typing in and getting any potential listings of what addresses match whatever the context of the user is beginning to type in. And you can use this with any table and then as well as any column, whether it's a string, numerical, date, whatever it may be. And then in terms of if you have some forms that you want to populate for your users, same thing using the statistics endpoint, I can go back and say, give me all of the distinct options. And this is actually a listing of wildfires. So I can simply go through and see all the potential options just to help you have a better UI UX experience for your users by pre-populating potentially or providing an autocomplete service while they're using your applications. I believe, yep, this one is the example of downloading data. So same thing here, I'm just hitting the collections, the root endpoint in terms of saying, give me all of the potential different data sets that I can use. So let's say I just wanted to do US state capitals, and then I can be prompted to download that data in a multitude of different data sets, whether it's GeoJSON, CSV, GeoParquet, GeoPackage, GML, and they just simply select which one they want, hit download, and then that will give them a zip file that will actually contain that data set, where then they can go and bring that into a desktop application, another software as a service that they may be using to go ahead and look at that data. And what's nice about this download endpoint that I don't have shown here is you have that filtering parameter as well. So if you are looking at an extremely large data set that you're hosting, you can give your consumers the ability to filter to basically narrow down and not have to download that entire data set. Another demo here, this is using more of the bins, the numerical breaks endpoints that are available as part of this API. And what I have here is by using the numerics endpoint, you can pass in different break types. So quantile, equal interval, heads, tails, and jink. And this will go back to the database and recalculate how to distribute that data, which I can then use to pre-populate this legend. And I can pass in different numbers of breaks that will keep going back and requerying the database to look at that. And then using the bins endpoint, I can get from a graphical perspective, how does that data look in terms of being scaled out with a majority of them, in this case being in the far left part of the column. But maybe if we go to a different one here, let's look at average household size. Now we can see for the most part, we have a totally different distribution here with the beginning part of the graph not having many within those initial bins. And this allows us to go ahead and easily see how that's all mapped out. And then going back to kind of some more standard OGC API endpoints using the, I believe it's part 4 of create, replace, update, and delete. We have the ability from an endpoint perspective. Let's say I clicked on Cook County here in Illinois. This will go and grab all of the attributes for this individual item. And I can go in and simply change, let's just say the population here to 999 people. I can go ahead and click update. And then if I actually go back to this previous demo here and refresh it, if I use the population, now you can see the population is 999 versus realistically, it's a much higher amount for the total population within Cook County. So very easily, you can kind of see, just made a simple interface here where people can go in and change these values, and then it updates in real time in the database to then be used throughout the other endpoints as well. And for my last demo here, wanted to show using, going back to OGC API endpoints, the items endpoints and the collections endpoint. We can go and select data as a GeoJSON format. And at first I'll kind of just do, if we wanted to draw on a map and say, find anything within the box that it intersects here, and you can actually kind of see what that SQL filter looks like that gets passed to the back end. But you can just as easily change this and say state abbreviation is greater than NM, hit filter. This may pull back a lot of data actually. I'm gonna go ahead and refresh that. So it looks like that did not work. But same concept kind of applies here, is you can go and pass in, just like the vector tile demo here, you can pass in whatever you may choose. So let's just say we do the counties, and I do population less than 1,000. Here we can see the same results, but this is actually pulling back GeoJSON data versus vector tile data. So with that, I will kind of open it up for any questions that anybody has.
Yeah, put the questions into the Q&A panel if you don't mind. So what was your motivation for doing this? I mean, I gotta say, like most people don't write OGC specified web service APIs for fun. Was there an employer? Was there like a problem? Was there a school task? Like, why did you take on such a big development effort?
Yeah, just always been interested in geospatial technologies, and wanted to build out and be able to use it on my own, and then give it the opportunity for anybody else if they were interested to use it.
Have you built any apps with it so far?
Nothing to like a large degree, no. But hopefully over the next year, I'm hoping to build something out that's more full-fledged versus kind of demos per se.
Yeah, that'll learn you. So I noticed you did the legends and the binning, which is
Yeah,
interesting to me. Is that an endpoint of your own invention, or is that specified somewhere?
that's one of the ones where it's not specified, where it's like if you are building a full stack application and you want to be able to do stuff like that, that wasn't something that was there. So I went ahead and made those that makes it substantially easier versus like you can, I know a lot of the like the TypeEG and uh, the feature server I think that you guys have, you can pass in functions, right?
Mhm.
But it's just not like a direct endpoint. So wanted to
Yeah.
try and make that easier for consumers then to be able to do.
Have you run into any scaling issues with larger data sets?
Not so far, no. Uh, Biggest thing that I've noticed is vector tile generation. Once you get a very large data set, if you're at those lower
Hmm.
zoom levels, like 5 or 6, it can become very CPU intensive, but I actually put a limit to basically prevent how many potential features you may render, so that at least helps to not lock things up.
All right. Questions from the crowd. What is the difference between this API and GeoPy API?
Yeah. Um, so I think from what I've understood with the PyGeo API is they're very locked into what is available for the OGC API standards, and they stick to those. I wanted to add a couple of additional endpoints that allow people to more easily work with and query their data, and then do things like the binning and distributions that weren't more easily found or be able to be built with these other projects. And then Philip asked for the
Does
fast
fast
collection.
collections work with any SRID?
Yeah. Um, don't know. I have not actually tried that myself. So right now, I'm simply just working with 4326. Um, but if you are interested, feel free to reach out and we can see what we can do with that.
And finally, does it include a built-in map client or web UI?
It does not include a built-in map client or UI. It's strictly just an API, and that's where I'm looking over the next year to actually try and build out more of a demo, full-fledged demo app that can use all the different endpoints so that people can better understand what they can or can't do with it.
Do you think there's any other missing endpoints, or you have to do the experiment first to find them?
Oh, I'm sure there's always more endpoints that other people would want. But at least for now, that's the ones that I could think of.
All right. Well, thank you so much for sharing this with us, Michael.
No problem.